In this next example from 8.1, we're looking at number 22. Here we're given the test statistic. It's already been calculated for us, and it's telling us that it was obtained when testing a particular claim that p was less than 0.3. It also, it's asking for us to find the critical value using a particular significance level of 0.05, and then using both the test statistic and critical value to make a conclusion about the null hypothesis. And so what's interesting is the test statistic and the critical value can really be done independently of one another. So let's go find that critical value. So what are we going to need to know? Well, what we need to know is what the claim is and also what the significance level is. So the claim is that p is less than 0.3. As you know, our null hypothesis is p is equal to 0.3. We'd love to be able to reject that. And our alternate is the same as the claim. So if you remember, our region where we're going to have our critical value is going to be in a region where the alternate hypothesis is true. So the question really is, where is H1 true? And it's going to be true. Picture the H1 value, picture the null hypothesis value, as being right here in the middle, 0.3. It's going to be true for values that are really less than 0.3, and we want it to be really, really less than. So this is what we'll call a left-tailed test, like we've seen in earlier videos. If you notice, the arrow in the inequality in the alternate hypothesis will point to the side that you should drop it on. And so this is 0.05 right here. Well, you know what this is. This is a z table, right? Because it was a test statistic related to a z. And so we're going to go use our z table. So let's go do that. Let's go take a look at our z table. See if I can pull that up here for us in this video. Now we need to find, if you remember, we had an area to the left of 0.05, and so we're just in here trying to find the closest we can to 0.05, and we found it right here. This little asterisk right in the middle is our guy, and so we follow that down and off to the side, and we get our critical value. Our critical value is negative 1.645. And so let's go back to our notes, this 8.1, number 22, and come in here and answer the question. Our critical value is negative 1.645. That's what we got when looking up that value. So we're going to reject the null hypothesis if we're in the tail region. So let me make that tail region really big now. So here's a bigger curve. Here's the 0.05. Here's the negative 1.645 as a z-score. Now there's a z-score of 0 here. Let me highlight something. Don't let this confuse you that we have a 0.3 up here and a 0 here. This right here, this 0.3, is a value in the claim. It's a percentage. This 1.645 is a z value. So as I vision that 0.3 in the center of that hump in order to decide which way to drop it on, that is just for a reference. It has a z value of 0. But we're wondering, are we more than 1.645 away? Well, let's go look. We had a test statistic of negative 2.50. That's way more. Where is our test statistic? This test statistic value, which was a z value of negative 2.50, it's back here. It's in the tail. It's in the reject, the null hypothesis region. This is the fail to reject the null hypothesis. Failing to reject it because it's either true or not super false, and we want it to be super false, so that's when it's beyond 1.645. So because we're at negative 2.50, we're going to reject the null hypothesis, and therefore we would have sufficient evidence to support the claim. Whenever you reject the null hypothesis, you can make a very strong statement about the claim. The reason why we're not writing that here is because of the question. They wanted us to find the critical value. We did by looking up the 0.05 in the table, coming up with the negative 1.645 benchmark critical value. We're going to reject if our test statistic is farther away from 0 than that, and it is. It is way beyond negative 1.645. It's way out here at negative 2.50. We're going to reject the null hypothesis in this problem.